Okay, so this is what we had at the end of the last video. And if I was to go into the console and get all of my field line points, you can see I have this array with 70 vectors in it, and each vector is just an x and a y position. And these all come from my getLinePoints function, which I created using Recursion. This function is over here, yeah. And this is way less lines than like what I was previously doing. So let's go ahead and implement this into what we currently have. So I'm going to copy that. So what we currently have up here with all of this stuff, some of it will keep. So we'll keep this whole like radius thing and starting positions. But once we have starting positions, we just kind of, we're not really gonna use any of this to do anything. Okay, so that all takes that away. And now instead what I will do is I'll call this function, and this function I will give it this starting position as like where it should be starting. I think I still need this line here. And okay, I have a whole bunch of errors, but we'll fix that in a bit. This gives me an array of points, but I'm not really doing anything with those points, at least for right now. So I will create a variable called points to store that array in, and then I will use an array function. This is a different one. We haven't seen this one. This is a for each. That's another thing with VS Code. If I just type in for each and hit enter, it like already does all that for me. So my array here is going to be points, and each individual index in there I'm going to call point, and that's going to represent like one, you know, like, so this whole array is going to be points, and each entry into this is I'm going to call point. So for each point in my array, I will get this vertex function here, and I will, instead of that -10 and 10, I will use point.x and point.y. Then I will also need this begin shape and end shape functions here. These are all in begin shape, end shape, and vertex are all inbuilt into P5. Lastly, I will give it a stroke. I'll just make that white for now, and that should be everything. I guess I can also give it like a no fill type of thing. I'll hit save, and what is going on? Okay. These are a whole bunch of errors. Where could this be coming from? So if I call, oh, that's starting positions with an S, so that's good. That's the whole array instead of just one individual point. Okay, so with one individual point, you can see I have this field line, which is kind of like what we had before. I just think it's a lot less code. It's easier to kind of look at, but I do still have some errors going on. Maximum call stack exceeded. Oh yeah, maximum call. Okay. So what's happening here is in my getLinePoints thing, I talked about how it's a recursive loop. It's going to keep going until it collides with something. But the problem with that is what happens if it never collides with anything. And that's going to happen. When that happens, I need to kind of set a limit to my recursive loop and say, keep iterating through everything until I either collide with something or I hit the limit that I need to set for myself. Because if I don't set a limit, it's just gonna bring out this maximum call stack error. So for this, I will say, I'll call this iterations, and I'll set that equal to 0. And then I will pass that into here. And then here I will say iterations plus plus. So what am I doing? So what I've done is I've said the first time I call this function, I'm going to have iterations at 0. And then every time I loop through it to get a new point, I will add 1 to my iterations thing right here. And then that's going to go into my next recursive loop, and then it's just going to keep going. So now I'm going to say if I'm not colliding with anything, and if my iterations is less than, let's go with 10 for now, then that's all good. Okay, so my error is gone, and if I drag this around, you can see that that's all working as expected. So 10 is a very low number. Let's go with maybe 100. That looks more promising. And yeah, you can still see I still have these like floating points right here, but the good thing about this recursive thing is if I upped this limit here, none of these lines would be affected. Only the lines that don't make it to the to collide with the charge would be affected. So maybe let's go to 500. Okay, that looks better. Yeah, that looks a lot better. And so I haven't talked about this before, but I think it's important. If you want to gauge the performance of your simulation, I'll put it in my draw function. I can say I'll put some text on the screen, and that text is going to be the frame rate. So there's just a function called frame rate that's gonna give me the current frame rate of the simulation. So if I just put that somewhere on the screen, yeah, I'm not sure if you can read this very well, but there is a frame rate right there. It's always changing. I can just round this for now to make it easier to read, and it's not going to take up as much space. Okay, so I'm in the 70s, which is really good. If I start to get like maybe to the like anything under 60 is when things kind of get choppy, but yeah, so right now everything looks really good. But if I was to do something, if maybe my recursion limit is too high, I might see a drop in my frame rate, or if I don't know, if I have too much going on at the same time. So yeah, I'll actually leave that up here for the rest of the series. I might actually just move it up a bit. Let's see, I'll move it to like the 20s range. Okay, cool. So that's all working. So I can actually just get rid of everything that I commented here. And I think that's, to me, that looks more organized than everything I had going on before. But the last thing that I think is going to be helpful with this is, and again, my frame rate right now is fine, but this is just one extra step that can help with people's performance, would be, I had that like long array right here, right now I have 500 entries into this, and this is just 500 to make up like one of these lines, and I have a whole bunch of lines. So all of these lines have their own arrays of points, which can get really like long and stuff. And as you can see in my draw function, every single frame I'm recalculating all 500 or so points per line in this, and so that's a whole lot of calculation. And so I'll save that for the next video. In the next video, we will I came up with a way to maybe like save the current state so that I'm not always calculating field lines, and then only recalculate everything when I drag charges. So yeah, I will see you in the next video. All right.